Hello friends, today we are going to see about partial derivatives. Okay, what's a partial derivative? Until now we have studied about the form y is the function of x. Like this, where is y is an dependent variable and x is an independent variable. We have only two variables here. Just think, if we have three variables, like z is the function of x and y. Like this function, how can we differentiate this? We already know about this. It's not that much hard with the same way. It will have two derivatives. One is for with the respect of x and one is for with the respect to y. Okay. So for the partial derivation, we usually don't use d. We use instead of d, we use this symbol. It calls dabba. So whenever you see dabba, it means it's a partial derivative. Okay, it's same as others also. Okay, this has only two rules. For the first one is when you do the differentiation with respect to x, you simply think y as a can you see? Yeah, constant. And when you differentiate with respect to y, take x as a constant. This is the simple idea. Okay, so just keep this on mind. Yes, and then it will be the same as like a second derivative is like if we write the second derivative for dy by dx, there's the same form. This is the second derivative with respect to x. Okay, and we have another one which called if we do the differentiation, if we differentiate this one with the respect to y, so we notate that like dabba y dabba x. It's the notation. If we it has to be 2 here, so the notation is dabba z over dabba y dabba x means the differentiation of dabba z dabba x with respect to y. So you have to do this with respect to y, and you same with the same way we can differentiate this one also. So these both will be same at the end. If we differentiate the both things at the end, if you differentiate these two with proper way, at the end you will get these two with the same number or same value. So if you write which is you are writing in front, that will be the you have to differentiate with the respect of that component. Okay, this is the basic things for the partial derivative. Okay, let's do some questions on these partial derivatives. So before we get into the questions, it's my small tip for you. After I write the question, just pause the video for some time and try the questions, and then play the video and check your answers and steps with me. Okay. The first question is z is equal differentiate dabba z over dabba x with respect to y. So 2x plus 2y. If we differentiate with respect to y, we will end up with 2 into 1. So the answer is 2. Then do dabba z over dabba y with respect to dabba x. So here 2y, this component will be 0. So if we differentiate 2x, we will end up with 2. See, these both are equal. So what we have done above is absolutely correct. The question is y is equal to 10z over x to the power 2. For our easy, to make our calculations easy, we can rewrite this as 10z into x to the power minus 2. So that the form will be easy for us to do. Then go with our same process. Here dabba y over dabba z. Okay, so we are doing with the respect to z. So here 10 into x to the power minus 2 will be the constant. So differentiation of z is 1. So we can write this as 10 over x to the power 2. Okay, then do the differentiation of dabba y over dabba x. So here 10z is the constant. Okay, what is the differentiation of x to the power minus 2? Minus 2 into x to the power minus 2 minus 1 is minus 3. So we can write this as minus 20z over x to the power 3. Okay, just cross check whether our answer is correct or not. So what can we do? We have to do like dabba z with respect to dabba x. So what is the differentiation? We know that 10 into minus 2 into x to the power minus 3. So the answer is minus 20 over x to the power 3. So if we do, the answer is minus 20 over x to the power 3. Okay, so do this one, dabba squared y over dabba x with respect to dabba z. So here we know this component dabba squared y over dabba z dabba x. So we know that this component is the constant 20 over x to the power 3. Differentiation of z is 1. So see, these both are becoming same answer. So the fourth question is z is equal to y into x to the power 4 plus 3x to the power 2 into y plus y to the power 2. So let's do the respect to x first. Okay, so here we know how to do this differentiation. 5 into 4, 20 into x into 4 minus 1 is 3 plus here 3y is the constant. Differentiation of x to the power 2 is 2x plus, so here y to the power 2 is a constant. So differentiation of a constant is 0. So the answer will be 20x to the power 3 plus 3 into 2 6xy. So just next do the differentiation with respect to y. So dabba y, here this component will be the 0. So 3x squared is the constant into y is 1 plus differentiation of y squared is 2y. Okay, let's cross check whether our answer is right or not. So here we double z over double x with respect to y. So here this one will be 0, this component will be 0, and see 6x is the into 1. So let's do the next one. Double squared z over double x into double y. So with respect to, we are doing the differentiation of this one with respect to x. So here that y will be this component will be the 0. So if we differentiate this, 3 into 2x. So the answer is 6x. See, those answers are same. So what we have done is absolutely correct. So yes, the fifth question is u is equal to x to the power y. So we can't do the question with this form. So what we will do, we'll change this into a log form, no? So log u is equal to y into log x. So now we can do the differentiation. So with the first we will do with the respect to x. So if we differentiate log u, what will happen? 1 over u into double u over double x is equal to, we have to consider y as a constant, into 1 over x. So the answer is 1 over u, u is x to the power y. So we can write it y into x to the power y over x. So this can be written as y into x to the power y minus 1. Okay. Next, with respect to y, no? So same, 1 over u into double u over double y is equal to 1 into log x. So it can be written as this, if this u comes here, log x into x to the power y. Okay, then we will just see the next one. We can write okay, double u over double y with respect to x. So what can we do? We have to differentiate this. So here log x, so is u into v format. So here we have to hold u here and differentiate y into x to the power y minus 1 plus x to the power y into 1 over x. This can be written as 1 minus 1. So if we take x to the power y minus 1 in the out, we can write y into log x plus 1. Okay, then we will do the, so then we will do the differentiation of w over double x with respect to y. So w over double x with respect to y. So we have to differentiate this. Before that, we have to know what's the differentiation of x to the power y minus 1. If only we can go further. Okay, then we will do that thing separately here. We will take z is equal to x to the power y minus 1. So here we can write this as log z is equal to is equal to y minus 1 into log x. So we can differentiate this with the respect to y, no? So 1 over z into dabba z over dabba y is equal to, we can write this as y log x minus log x, no? So we can write, so if we differentiate this, okay, y into log x minus log x. Okay, if we differentiate this, what will be the answer? Log x minus 0, no? So 0 will be here. So what's the differentiation of this will be log x into x to the power y minus 1. So just simply we have to substitute here. So so this is the u into v pattern, no? So what can we do? Because here is y is also here. So x into y minus 1 plus y into the differentiation. So log x into x to the power y minus 1. So what will be the answer is, when we take x to the power y minus 1 in the outside, there will be 1 plus y log x. So these two are becoming same. So we can assure that our answers are correct.